Okay guys, so now let's take a look at the example number 1 of the section 4.3 part 2. We need to calculate the LCD, so we are going to write all the denominator, and I'm writing 1 also, the 1 divided by 1, the denominator 1, because I don't want to forget the LCD. I don't want to forget the denominator on the right side of my equation, and sometimes some of you are going to forget that. Anyway, at the end of the day, when I completely factorize 1, it's going to be 1, and 2x plus 1, there's nothing that I can factor, so it's going to be 2x plus 1. And so my LCD is going to be 2x plus 1. So when I multiply 2x plus 1, my fraction x plus 2 over 2x plus 1 equal 1 times 2x plus 1, because I need to multiply by the LCD both sides. I realize that now I end up to have x plus 2 equal 2x plus 1 multiplied by 1, which is 2x plus 1. Therefore, I'm subtracting x, I'm going to subtract 1, and I end up to have 1 equal x. That is the solution of my equation x plus 2 divided by x plus 1 equal 1. Let's take a look at the example number 2. So I need to calculate my LCD. My LCD, I'm going to take the 1 divided by 1, first denominator. I'm going to take the x, and I'm going to take the x squared. Completely factorize into prime each denominator. So I'm going to have 1x and x squared. And when I calculate the LCD, define the LCD, it's the multiplication of each factor with the highest power. In that case, we have power 1, factor 1, so 1 times. It's not going to change anything. Then we are going to have factor x to the square and factor x to the 1. Right there, it's to the 1. Therefore, I'm going to take x squared because I'm supposed to take the factor with the highest power. Now, if I multiply by x squared both sides, I end up to have x squared multiplied by 1 minus x squared multiplied by 13 over x plus x squared multiply 36 over x squared equals 0 times x squared. I know 0 times x squared is going to be 0. I could do that in my head, but if you are used to do that for a long period of time, you will be able to, many times I want to say, you will be able to do it in your head. Otherwise, sometimes instead to have 0, you're going to have a 3. And because you're not used to multiply both sides, you're not going to multiply your 3 by x squared. Therefore, you will make a mistake by multiplying by the LCD only on one side of the equation. My battery is low, so let me change that. Take care of that. All right, so I took care of my battery. So now I'm going to end up to have x squared minus 13x plus 36 equals 0. You could try to factor this quadratic equation. What I would like to do is keep continuing to add a plus to make sure that I have x squared plus bx plus c. That will help me to not to make any mistake in defining what is the value of a, b, and c. A equal 1, b equal negative 13, and c equal 36. The last thing you need to do is substitute substitute value a, b, and c inside your quadratic formula, and you will find a minus b, so minus negative 13 plus or minus the square root of b squared, negative 13 squared. You will notice that every time I'm dealing with a negative number, I'm putting this negative number in between parentheses, minus 4 times a, which is 1, times c, which is 36, divided by 2a. Now it's just a question for you to take your calculator or divide it by 2 times 1. Sorry for that. So divided by 2 times 1. Then it's just a question for you to take your calculator, plug this number inside your calculator. Sometime with your calculator, you will have to use a parenthesis right here. And you will find the two values. One will be with the plus and the other one will be with the minus right here. Example number 3. In this example number 3, it's a good example because we are having x minus 2, we are having x plus 2, and we are having x squared plus 4 for the denominator. I need to completely factorize each of these denominator in order for me to define what is my LCD. X minus 2, there is nothing that I can do, so it will be x minus 2. X plus 2, same thing, x plus 2, nothing that I can do. Now, x squared minus 4, and I made a tiny mistake because I put plus 4. So let me put minus 4. Now, x squared minus 4, remind me that it looks like a squared minus b squared, as 4 it is 2 squared. Therefore, I know that it's going to be x plus 2 times x minus 2. And I end up to have x plus 2 times x minus 2 as your LCD. When you multiply by your LCD both sides of your equation and each term of on each side of your equation, you end up to have x plus 2 times x minus 2 multiplied by x over x minus 2, x plus 2 times x minus 2 multiplied by, oops, no, I don't want to delete that. I don't know what happened right here, so don't delete. Let's go back to the section 4.3. Okay, I'm sorry for that. So x plus 2 times x minus 2 multiplied by 1 over x plus 2 equal 8 over x squared minus 4 multiplied by x plus 2 times x minus 2. Obviously, I know that x plus 2 times x minus 2, it is x squared minus 4, x plus 2 divided with x plus 2, x minus 2 divided by x minus 2, and now I end up to have x times x plus 2 plus x minus 2 multiplied by 1 equal 8. I distribute x squared plus 2x plus x minus 2 equal 8. And I end up to have, at the end of the day, the quadratic equation, x squared plus 3x. I move the 8 on the other side by subtracting 8 both sides, minus 10 equals 0. A quadratic equation. To make sure I'm not making mistakes on a B, and C, I'm going to add a plus. And now I know pretty easily A equal 1, B equal 3, and C equal negative 10. And then you just need to use your quadratic formula. Okay. All right. So step number 1 in the example number 4 is solve as if it was equal to 0. So the first step is to take x plus 1 divided by x minus 4 and make sure that it's equal, and we want to solve that equal to 0. We could multiply by the LCD both sides, but you need to remember, when you have an equation a over b equals 0, the only way that your fraction is equal to 0 is if your numerator is equal to 0. Therefore, in that case, x plus 1 equals 0, that gives me x equal negative 1. Okay? Second step, find the domain where the denominator isn't equal to 0. Well, the denominator isn't equal to 0. You are going to have x minus 4 is different than 0, cannot be equal to 0. I remind you that the denominator cannot be equal to 0. Therefore, we get x different than 4. Now, I want to make a number line. Here we go. All right. And when I make this number line, I'm going to plot the 0, and then I'm going to position negative 1 on this side because I know negative number on the left of my number line, and x equal 4 on the other line. All right. Now what I can do is pretty much defining 3 intervals. Okay. Interval number 2 and interval number 3. Choose the value of x in each interval. X equal negative 2. I'm going to take x equals 0 right here, and x equal 5. And check in this interval if my function is greater and equal than 0. When I substitute in the interval number 1, I end up to have negative 2 plus 1 over negative 2, negative 4. That gives me a negative 1 divided by negative 6, which is 1 over 6. This is greater than 0. That is okay. when I look at the interval number 2, x equals 0, and end up to have 0 plus 1 over 0 minus 4, which give me negative 1 over 4. This is less than 0. It's not greater or equal than 0. Therefore, this is not okay. This is no. On the interval number 3, I end up to have a 5 plus 1 over 5 minus 4, which is a 6 over 1. This is greater than 0. So this is okay. Now I can write the interval notation because I know this is yes, this is no, and this is yes. And I can easily write minus infinity, negative 1, bracket, union, parentheses, 4 plus infinity. Solve and write your answer for the example number 5, as well as the example number 6 by yourself. Example number 7, example number 6 regarding the inverse variation. Let's do the problem number 6. The intensity of light vary inversely. So first of all, I'm going to write I for the intensity of light. I can name any way I want. So intensity of light is one variable. The vary inversely as the distance squared. So I'm going to call D for the distance. And because the intensity vary inversely with the square of the distance, so I could transform that value with the inverse of the square of the distance, so k times 1d squared. Now what is the question? Find the intensity. The question is find the intensity. So to find the intensity, I need to know the value of k, and I need to know the value of d. They tell me find the intensity when the distance is equal to 2 meters. The point is, they're not telling me what is k. So I need to find k. To find k, from the formula that I was able to define, I'm going to express k. To have k standing by itself, I will like to multiply by d squared both sides. Therefore, k equal I multiplied by d squared. To find k, I need to know I and d. Well, if you look at the problem, they are telling you the distance, when the distance is 3 meters, the intensity is 88 watts per square meter. So we have 88 watts per square meter, and the distance is 3 meters. Therefore, now I can find k, because I can write k equal 88 multiplied by 3 squared. Okay, so let me take my calculator. So now we have a value of k equal 792. I can go back to the calculation of my intensity, because now I can write that k equal 792, and therefore I can calculate the value of I, which is going to be 792 multiplied by 1 over 4, as my distance is equal to 2 meters. And so now the answer divided by 4 is going to be an intensity equal to 198 watt per square meter. All right, guys, I think I will let you finish all the other problems, 7, 8, as well as the rate of work. These problems are very important. You need to spend some time, and we will continue our work in class together. Have a good day.